discussion. I'm Ashley Turon-Ord, your host for today, which is brought to you in partnership with Nokia. It's my pleasure to introduce today's moderator, Dominique Verhulst, Global Energy Segment Leader for Nokia. We would love to hear from you during the session, so we encourage you to please send your questions through to our panel for live response using the Ask Staff a Question box on the right-hand side of your screen. We will attempt to answer as many as time allows. Today's webinar will be available on demand after the live session, which you'll be able to find on enlit.world. I will now hand over to Dominique to facilitate the discussion. Over to you, Dominique.
Thank you so much, Ashley. Hi everyone, welcome to today's webinar, and it gives me great pleasure to introduce three very experienced panelists on our webinar today. We have with us Alberto Sandin, the head of the telecommunications at Iberdrola, based in Spain. We have also Gregory Muller, who is managing the network at Creos in Luxembourg. And we have Clinton Struth with us, who is the principal engineer of SCI Networks from Canada. Welcome, Gregory, Alberto, and Clinton. And I'm looking forward to today's conversation, as the topic of the discussion really is evolving from a telecommunications network in a power utility from a legacy TDM environment to a packet network. And let me just kick off with the first question here. What were the key drivers for you to transition from TDM and or SDH SONET to a packet network? And maybe, Alberto, we could start with you because you have some experience that goes back to more than 20 years in that field, right?
Yeah, thank you for that, Dominique. Yeah, it's also my pleasure to be here. We can call ourselves veterans, or at least understand that we started really soon, more than 20 years ago. In my mind, I have year 2004 when we started, well, not really started, but consolidated the effort of deploying the first IP MPLS network. At that time, we didn't even mention IP because it seemed a bit too complex from where we came from, and we focused on MPLS itself. Let's say that Iberdrola in Spain, we are, as a telecoms department, delivering services to the different companies we have. So that means we have quite a diverse group of services and internal customers. And we try to be a kind of telecoms carrier to them. So we try to avoid any complexity. So at that time, we were kind of moving from a frame relay network. You remember frame relay? So we did not make the error or going into ATM and understanding that the prevalence of Ethernet and IP interfaces started to be over there, because one of our main customers in terms of bandwidth, it was the IT department. So basically we started to explore Ethernet-based solutions. We had quite an experience with Ethernet transport. We were moving from plain TDM, PDH towards SDH. And at the time we did that, we engaged with the new generation SDH that was capable of transporting that Ethernet. So it was kind of natural for us to combine the MPLS network, a very tight core of it, and then transporting from that core to the edge, let's say those Ethernet interfaces, wherever they may take in. We also had the feeling that, let's say, RS-232 interfaces were kind of obsolete, and that those were the main drivers.
Okay. Thank you, Alberto. And Clint, I think you have had quite some experience as well from the power utility companies you've been working with over the last 15 or 20 years.
Yes, Dominic, and like Alberto said, certainly our experience was similar, going back to approximately 2007, 2008. The legacy technologies that were in place there with the SONET TDM, and in my first utility with ATM over SONET, of course, all of those technologies were seen to be, I guess, declining in terms of deployment and sort of life cycle. You know, at the same time, you know, I guess that equipment was going obsolete effectively, and we knew that there was going to be a need for a new solution. You know, we're always looking further ahead to see what are all the applications doing, and as I'm sure as you'll hear here from the others as well, there was a general theme of creating an internal utility carrier model, which was to consolidate the skill sets largely, but also the technology into one platform that could deliver services to all of the corresponding stakeholders and business units. That in combined, you know, in conjunction with you know, the obsolescence of the legacy technology is what really sort of put us onto a roadmap leading to what would be the best solution from a carrier perspective to provide all of those multi-service sort of IP or Ethernet type solutions. So that was really sort of the I guess maybe one of the core drivers. Perhaps a secondary driver was to also look at some of what are the improvements, what are the additional features, functions, and things that we could do if we went down that IP model. And you know, for the utility where I was, of course, it was transmission. So we also had to validate things like teleprotection and certainly the wide area SCADA networks and all the corresponding voice and land mobile radio and all of those sorts of solutions and services. So definitely needed to dig into it in depth, but you know, to prove it out, I guess, effectively and show that you know, some of these new technologies could do it. But there was also an underlying desire there. We certainly realized that you know, from a perhaps more diversified model within the utility being managed largely by the field support folks, we definitely wanted to create the centralized organizational model with a network operations center, and sort of have those core skill sets, if you will, operating things from a central perspective. And then, of course, as one can realize too, in North America with the NERC CIP standards and those kinds of things coming into play, we certainly realized those were going to have a pretty heavy impact onto any kind of a solution going to IP. So we wanted to make sure that all the skill set, all of the technology capability and so on was available in those new platforms. So there was all of those kinds of pieces that were feeding into it, but certainly first and foremost was the equipment obsolescence. That was the big one, and it continues to be that way.
Yeah, that's clearly one of the major issues we see. So, so you've made that transition to packet technology. Maybe you can talk a little bit about what were the major hurdles you have experienced in your journey to, you know, in the journey towards a packet network, and I'll come back to Gregory in a moment, but maybe Alberto, you could brief us a bit on what you saw as major obstacles or difficulties. Was it like was it a technology issue? Is it knowledge? Is it people? Is it resource? You know, what were your challenges?
Eventually, it all boils down to people. In our case, I have the perception that it was kind of, let's say, internal resources to deliver services, and both customers on the one side, coming to internal technicians that had to deliver these services. Probably their age was such that they were not educated in this world of Ethernet and IP. So it took us the time for them to get comfortable. And we kind of had to start slowly, start with simple services that were very similar to the ones they already knew. For us, that was layer 2. So we stick so much to layer 2 that they could get with overtime and training, because clearly that was also the case, to learn the basics of those technologies. But here you cannot neglect the role of the customer. In the end, we believe in the customer itself. We cannot impose solutions, so they need to be comfortable. And there, probably there is a mix of both knowledge that it is also existing in that case, but I would say also operational comfortability. Basically, they already know how to handle problems when they raise in the old TDM SDH world. When it comes to this new technology, well, things start to be kind of less redundant, because you just need 2 connections to do separate sites instead of a bunch of wires connecting everything. So you at first you don't believe it will work, but well, along that process, it was possible.
Now, when you mention customers, Alberto, you mean your internal customers?
Correct.
the telecom
Yeah.
service. Your customer is the SCADA team, it's the protection guys.
That's correct. Probably I would need to elaborate a bit further because when I first jumped into it, I mentioned that one of those customers, which were the IT department, provided these corporate services, let's say connectivity for PCs and rest of applications. They were one big customers when it came to bandwidth needs. But clearly behind those, you have the control of generation plants, you have the control of substations, both primary, secondary. You also need to consider protection, also the connectivity among the control centers. So for us, all those guys and all those elements we connect through our networks are customers. So we live in the internal customer as a customer.
Yeah, and so, you know, to give maybe the audience a bit of an idea of that the time it took you to take you through that journey from the early beginnings when you made the migration to packet networks, when you started and until what you consider to be finished, or maybe it's not finished because there may be still applications that you want to transition. I don't know. So could you give us an idea of what the average time span would be of that?
Yeah. Well, let's say that as we started in 2004 with, let's say, the deployment of the first 6 nodes that basically were kind of substituting the old frame relay devices. It took us probably 2 years till we started to be comfortable with the operation of that. Along that time, we kind of created an architecture in which we could think of delivering any service that was already delivered to our customers using that network. Well, typically layer 2 services and encapsulation over IP MPLS to transport it. So that was clearly a year 2006, and then it was a process, a progressive process with different customers. I think we started first with the connectivity of control centers. We have, let's say, 6 sites in which we have control centers, so they wanted to be interconnected, and they have also the shadow places. Clearly, that was a very important site to be covered by this. In other services, we started more slowly. For example, if I remember generation, they had already been engaged in a project to change all their connectivity to, let's say, a V35 interfaces and all that. So they were not so willing to move first, so they stayed behind. And IT clearly were the ones to benefit from here because the scalability of IP MPLS connectivity coming from the world of V35, it is clearly there.
Yeah. Coming to you, Gregory. The process started in Krios already, I think, 2012, 2013.
Yes.
So the start was already quite some time ago, but in terms of the evolution and the migration of the network, including some of the applications, etc., you know, how long has it taken Krios to complete this task?
Yes, thank you, Dominic. So as you know, I was not involved in the very beginning of this project, so TDM migration, but I think that the obstacle, because I will just speak about the obstacle and the hurdles, are for me still the same. So we are, like my colleague said, support team. So we have, our goal is only to make the connectivity for them to work. So, but sometimes we have to convince them that we are working for them, because they are, I don't know what they are, the change, they are afraid about change, and we have to convince them that we are working for them, and the migration that we plan to do is only because of the obsolescence of some protocols, of some devices, and we have to be very empathic and I think pedagogic about how we will do the migration. And I think this is very important for us, because even today, even in the era of automation, intelligence, artificial, we are still working with many serial devices and legacy protocols, and we have to explain why we have to migrate it, even if it's still working. In the long time ago, and with the station, we planned it for I think 20 or 30 years, but we have to plan it to migrate it because of the obsolescence of the protocols and the devices. So I think that for me, biggest obstacle is always to convince and to make it smooth for everyone, discussing about the impact, what we will do in which order, and this is also the reason why it's taking so much time to achieve that.
Yeah, because I think because of these legacy systems are so deeply integrated into the grid protection, automation, and control systems, it's not easy to replace that or to change that, right? So, and that brings me to the next question, actually, for all three of you. If you look at the applications that you are supporting for your customers on your networks, how much of that would be like native layer 3 versus layer 2? Alberto, you already hinted a little bit on that earlier, but there's still legacy stuff for which you might be doing circuit emulation. So maybe you could give us a bit of an idea of the mix and how you see that evolution. Maybe Clint, you could give us your perspective on that first.
Sure. Yeah, like with the the classic suite of services, as I like to think of it, that are evolving in parallel with the network that's being upgraded. Of course, in the previous network world, the TDM sonnet or SDH world, of course, everything was point to point. But what we've seen over the last 15 odd years, for sure, is largely teleprotection is sort of the last one that will probably evolve, if you will, into more of a point to multi-point type of architecture, or certainly a packet one. For the most part, those types of services are still remaining as pseudo wires point to point. But everything else, even the ones where we had originally deployed them as like a VPLS or a point to multi-point layer 2 type service, the majority of those are evolving into layer 3. And going to like a VPRN type service. Pretty much all of them have that kind of I guess a roadmap or a conversion, if you will. So yeah, you're right. I mean, from the perspective of what kind of MPLS type services or multi-point services are we using, there's sort of these point-to-point pseudo wires, and then there's VPL or VPRNs for everything else. So that's pretty consistent across all of the different utility networks that we're working with. That seems to be I guess the main thread. So yeah, maybe I'll pause there and see if the others agree, but that's what we're seeing.
Yeah, what about your network, Alberto? How do you see that mix of layer 3 versus layer 2 and or circuit emulation legacy services?
Yeah, as you say, probably I made the spoiler at the beginning, at least, and left some hints that you can probably track. Well, our interest has always been to keep simple, and simple for us means several things. First one is, let's say, layer 2 services as much point to point as we can. If not, we go to the level beyond, which is a big switch. So to the extent that the scalability of the premises to be connected and the solutions to be connected do scale, clearly we try to go that way. We had a massive disruption of that idea when we started with the smart grid. Basically, when we transition from connecting primary substations, we have, let's say, a bit more than 1,000 of them, to connecting 100,000 secondary substations. So that increases the volume. And beyond that, we had to revert to also combining this with public networks, public commercial networks. In those cases, if you go to cellular routing and all those type of stuff, clearly those are natively layer 3. So you cannot probably integrate them easily if you are using just layer 2 on your side. So it was a major, let's say, process for us. It was kind of 2 years till our infrastructure was increasingly adapted in terms of well, the baseline services in the core of the network, exporting that and taking that closer to the edge. So it was kind of interesting. What we don't know is circuit emulation. And again, this connects with kind of simplicity, or I would say sustainability. We tend to be really simple with the boxes. I'm referring to telecom devices. We try just not to diversify so much on the boxes themselves and on cards. So we stay on the cards that we feel are going to be sustainable. Well, feeling is a way of addressing that. Clearly, we go more technical than that. But if you think on how we connected those first IP MPLS network elements, we had first the the idea of connecting them directly with some cards that were offered by that solution that could be connected in TDM to the SDH network, but we skipped that. So basically we said, let's connect in where it is native for IP MPLS, which is Ethernet, gigabit Ethernet, and then let's make the new generation SDH cope with that Ethernet interface I'm connecting. So it happens the same with this circuit emulation. Any vendor, any product can support this, but well, you go to some implementations that even if they are standard, there are little subtleties. Some vendors, those things change in product portfolio. So we prefer to do it that way, stick to layer 2 where scalability allows, move into layer 3 when there is no better alternative in layer 2, and skip circuit emulation by means of encapsulating outside and connecting in plain Ethernet. Let me mention one very small thing. For example, primary substations, we connect them in layer 2. This has been demonstrated to be really good for us in terms of cybersecurity. When it gets to connecting to primary substations, and you think in NIS and NIS2 and these European regulations, well, when the regulator, anyone checking that, sees that there is layer 2 tunnel, everything perfectly isolated from the rest, I mean, they feel happier than if they see just a layer 3 network where other devices need to be put in to control that.
Yeah. I think Clint also alluded to that for NERC SIP, which is then in North America, something that you need to be mindful about. And then also at layer 2, you can obviously also encrypt all of that data quite easily and at scale. But coming back to you, Gregory, with regards to layer 2, layer 3, and circuit emulation, you have quite a bit of transmission assets as well in Creos, right? So can you give us a bit of an idea of where your mix sits in terms of layer 3, layer 2, circuit M?
Yes, for the SCADA services, so bringing the connectivity to the data center for measuring and make the smart grid working. So we had, I think, the last 5 years did many migration from the serial controllers to IP1. So I think we are doing the same than Clint and Alberto. So the medium voltage station in layer 2 until a big station that is carrying the layer 3 network. We have still some very old station, but very big station also that we have a project to be upgraded. I think it 5 or 10 years, the next 5 or 10 years. But I think that with a percentage, we have about 70% of IP or VPLS layer 2 networks. And I think about almost 100% for teleprotection using CSOVP
circuit emulation.
Circuit emulation, sorry.
Yes. Yeah. So that's for current differential protection in your case, then?
It's yes.
Yeah. Well, actually, that brings me seamlessly to the next question, actually, because line differential protection or 87L often is like the elephant in the room, right? When we are moving to packet, the question is, of course, what is your view in terms of the evolution of these applications? Do you see it evolving to Ethernet and moving to IP? What sort of time frame you are looking at for this to complete? Maybe Clint, you could start off with that.
Right. Sure. Just as a thought, as an extension to the last question there. I mean, certainly MPLS is fundamental to this, right? Because of the nature of the protocol and how it has the ability to sort of isolate or separate the different service constructs. That is sort of fundamental to the overall architecture. And to your earlier comment about NERC SIP and security and keeping different services isolated and so on. So that then extends into to your question, certainly about teleprotection and what can we do. We've clearly had solutions of all types of different teleprotection and protection schemes using all different types of serial interfaces and so on. And we do those with pseudo wires on the MPLS currently. But you're right. The main question that everybody seems to be wondering is when will these solutions ultimately go packet? You know, here in North America, certainly, and with the utilities, or many of the utilities that we've been working with, I mean, the sheer scale, the number of relays that are out there in the tens of thousands, it's going to take decades for these kinds of things to be upgraded and changed out and flipped over to an Ethernet type of transport. But that logistical exercise, I suppose, is one problem, but validating that there is in fact a new solution model that we can move to is perhaps where we are currently. You know, we have seen several utilities that we work with now, in particular with 87L and current differentials, you know, with new relays and new protective devices going in, certainly looking to go Ethernet as much as possible. Now, whether that's a native protocol that is proprietary to the relay manufacturer, or whether that is something perhaps a little bit more standardized, such as 61850 or you know, goose messaging and routing to goose and those kinds of things, is sort of dependent upon where the utility is and their comfort level with it. But you know, from a service provider or a service architect, if you will, looking at the MPLS technology, you know, really the goal that we have is to make sure that we can accommodate any of those. So whatever they come to us, and meaning the relay folks, whatever they come to us with a stakeholder need, you know, we want to make sure that we have a solution that is ready, that can meet those requirements and still not compromise, you know, latency, asymmetry, you know, encryption, security, all of those kinds of things that we're looking for. So you know, so that's really where we're at. But we have seen several, like I say, utilities here in North America now that are actively deploying 87L on Ethernet. So it's sort of the last, you know, the last solution, if you will, that needs to be solved to really take any of the other applications, you know, and to be able to say, you know, quote unquote, that the whole network has gone packet. So I think we're there. It's just I think just the logistics of the protection schemes themselves and the timeline with which those assets are upgraded will really be perhaps the, you know, I don't want to say constraint, but that'll be really the limiting factor on how fast we can move those to packet.
Yeah. Gregory, any view on that? Like moving to Ethernet on protection systems?
Yes, like I said before, we are about 100% migrated to circuit emulation, but we already are preparing, are doing labs with the main provider of teleprotection at Creos, and we are trying to prepare the guys, the teleprotection guys, to also explain them what we have to do and what we will do in the 5 or 10 next years about the migration to Ethernet packets because of some technology obsolescence and probably that the chips of the hardware that will be stopped in 10 or 15 years. So yes, we are doing some labs and working with the main provider that is already ready to make this, and with his support it will be better and easier. It will facilitate the way that we have to convince the teleprotection guys. But I think now it will be smoother because the first migration with the circuit emulation was pretty smooth. So we gain like a trust with those teleprotection guys. So now they also noticed that it's working like before, and we are also consuming less of fiber using the packet. So we have many advantages, and I think that they are also aware of that.
Yeah, it's building trust, it's building confidence, of course.
Exactly.
But I guess the move to Ethernet for protection, automation, and control will also open up new possibilities and more flexibility for the protection people. New schemes, better centralized protection automation,
Yes.
wide area protection automation. So I guess there's a lot of potential that is untapped there. So maybe Alberto, what you could give us a bit of your views on that evolution as well.
Yeah, well, that part of our customer services is probably if utilities are very slow moving animal, this is the slowest moving animal in all. I think probably any transition into this or any further focus on giving, let's say, this a higher priority will involve whatever needs to be the next bigger project. What I see is that there are not so many primary substations, new of them built. There are not many refresh projects for protections all over. So that being the case, as a telecoms department, we prefer to focus, let's say, on the wider set of other services that, let's say, do deserve, in the sense of the customer asking for change, more attention. The other thing is we are also deploying IP MPLS along with transport technologies. We are using extensively the optical fiber network. We kind of spoiled part of it and giving it to differential protection with no transmission device in the middle. But when we put IP MPLS, there are cases in the core part of the network where we connect that to a DWDM device. And once we have the Ethernet interface to be transported there, as this is mostly point-to-point, we solve it the easy way. Okay. But I mean, technically this is solved. You and I have seen this evolving. It has been so slow, as I mentioned. First the standard, second the first vendor, then the next. So in any evolution into this, I think we need to be sure that vendors did really interoperate, and that keeps on happening when firmware upgrades happen and all that. So that comes with some further complexity as well. Right.
I agree. Now the 87L teleprotection, line differential protection term has actually been dropped a few times here. So for many people, this is still like the biggest kind of difficulty or hurdle to overcome when they're considering a migration to packet networks. So maybe Clint and Gregory, you could give us a little bit of an idea of how long you have actually been running current differential protection across your IP MPLS network. Years. Maybe Clint, you could start.
Sure. Yeah, I mean, obviously, current differential protection has a specific set of requirements, and a very specific set of controls that need to be in place as it relates to, not just end-to-end latency, but asymmetry as well. And so clearly, there's a very specific design that is needed in order to do that. But when I think back to when we first, proposed migrating that kind of an application over onto MPLS and the testing and so on that we did. That would have been 2008, 2009 sort of time frame when we completed that testing and sort of validated the design architecture, if you will, or the solution. Since that time, I would say the configurations, if you will, or the standardized config model really hasn't changed a ton. Effectively, we've deployed it in many locations, and to the point now where we have literally thousands of teleprotection circuits of this type, running on this kind of a network transport. So it's a very solid, a very tried and tested model. So like I say, going back to 2008, 2009, so 15, 16 years at least, that those kinds of solutions have been in production deployment. So, I don't know if that's specifically kind of the answer, that you're thinking of, Dominic, but yeah, no, it's a very, tried and true model, I think.
Right. So we're talking about 10 plus more years of, 87L services running across these
right.
IP MPLS networks. And I guess also in Creos, Gregory, you've been running that for quite some time already now?
Yes, about 10 years. In 2017, we did many workshops with our main provider about how to configure effectively all the setups, so the symmetry and the timing of each packets in order to optimize in our network all the settings and to have a blueprint of our configuration, and also to demonstrate to the teleprotection guys every time, to demonstrate to them that it will work. And we have also make many demonstration about the redundancy, the scalability, and so on. And so I think that we began, yes, in the beginning of 2018. So 6 months of tests, of intensive tests, and many workshops about that. Mm-hmm. And I think that we have now 300 or 400 teleprotection, line teleprotection, and differential also using the C37.40.94 sorry protocol for now. Yes.
No, that's good, excellent. So now we talked about IP MPLS, but I guess you know there's other alternatives. You know, when you have to make a decision to move from TDM to packet, there are different options, right? You could go IP MPLS, you could go MPLS TP, you could go carrier Ethernet. So maybe it would be good to get your perspective on why you actually ended up making the decision to go with IP MPLS. And I'll start with you, Alberto, because you made that decision for the longest time ago. So
yeah, first I need to apologize. There is a fire alarm somewhere. I don't know if you can hear it, but anyway, if you cannot hear it, it's better. Probably it's a false alarm. If you see me running, it was for real. So don't. It won't be a problem. Now, coming to this thing, in our minds, this comes as mainstream versus the rest. We see kind of IP MPLS, and even if there was not, let's say, a solid unique solution at first, we see it as the mainstream technology, and beyond it, well, MPLS TP was developed for certain reasons. If you think in carrier Ethernet, probably it's also an evolution to fit a market that was not already solved and was, let's say, natural for Ethernet vendors. So in the end, we believe that this is not just pure technology. This is not just bits and bytes. You need to find the ecosystem in which you fit better. As we see ourselves as a carrier, telecoms carrier, we think we feel we fit better in this kind of spaces. The other important thing is, and this is very evolutionary for us. This is not just a project, it is taken to the field. You buy this purse and it will be there. We just start small, then we continue evolving. We need to guarantee that a long period of time, you will have no hiccups with vendors, with product portfolios changing, and we think we are safer using, let's say, mainstream technologies. So possibly that is why IP MPLS was better for us, not to become part of a niche that has its sense. Probably it makes much sense for many companies, but for us in our specific situation, it didn't.
Right. Clint, I saw you nodding a few times there
Right.
while Alberto was giving his perspective. What's your take on this? You know, which technology and why the decision was made for IP MPLS in your case?
Right. Well, I mean, from my previous role, I guess as the principal engineer and planner of a large scale transmission utility, you know, you have a perspective of clearly there's a technology upgrade that needs to be made, and we know there's a skill set and a learning curve that will come with that. So there's always a question about what's the time it takes and the complexity, and you know how long is it going to take us to adapt and learn that technology. And so that's sort of one, I guess, maybe underlying factor. But life cycle and timeline to me are always the biggest questions. And we know the previous technologies had fairly long life cycles, right? In excess of 20 years, even 30 years in some cases. The new technology world perhaps isn't quite that long. And so, but that being said, we still have to go and we still have to come up with a financing model, and we still have to justify the project. And you know, we kind of have one shot to go and do this. And so there's always a question that ultimately comes out of it, which is to where do you place your chips? You know, and of course, at the time when we were initially looking at some of these solutions, such as MPLS TP or carrier Ethernet or IP MPLS, you know, it's a bit of a question. And so, you know, my perspective on it was to look at what were the carriers doing. You know, similar to what Alberto said, you know, we were effectively deploying and creating our own internal carrier service model. And you know, to be quite honest with you, the longevity, the life cycle of the product platform will follow the money. So if the carriers are all going in one direction, that is, you know, likely where the investment is, the deployment base, all of those kinds of things. You know, that is really sort of one of the main factors where, you know, that pushed us, if you will, towards an IP MPLS type of solution. But beyond that, we also, I think, we're cognizant of the fact that the solutions, the services, the applications were evolving. We knew we were going to need very large scale. We knew we were going to need capability of, effectively layer 1, layer 2, layer 3 types of service models. We had to look for compatibility. Clearly we had to have a solution that was backward compatible with everything that we had on the TDM and solid environments, as well as all the new features that we wanted for the new network going forward. So, there were some other pieces like that certainly came into play. I know another one, just to maybe wrap up my point, but is sort of this risk tolerance question that comes up, right? And do you invest in a small market player or smaller market player versus the handful of very large scale global manufacturers and vendors, right? And then that sort of feeds into a risk tolerance type of question. All of those kinds of things, factored into the decision, which I think aligns with what Alberto was saying. That's really where I think the clear, front runner, if you will, was an IP MPLS solution.
Right. Yeah, I guess also in the operational sense, having a more dynamic capability is probably also, making life easier as networks are becoming more meshed and you add nodes into a ring, etc. You need something that will, quite easily give you that capability. What about Krios? At Krios, Gregory, the technology choice there for IP MPLS versus other alternatives. What's your take on that, or what's your experience basically?
I think the main driver was the technology, the capability of the system. So we had, I think, if I remember because as you know, I was not at the very beginning of this project, many converters, serial converters, and many technology converters. And the first or the main driver of this project was also to unify all the device or all the technology on one device. So with the IP MPLS, we can also use L2, L3, make layer 2 tunnel, so like extending just with a wire, and also transport serial and so on. So I think that it was pretty beauty for and this is, I think, also a big driver of this choice about that. So yes, the fact that we can do everything that we would like to do.
Right. Now, I see there's quite a bit of questions that came in, and we probably need to take some time to address some of those. But one key element that I wanted to bring to the table is the importance of network and service management, because you move to a new technology, you move to packet networks. Ultimately, you put all of your services onto that network, your SCADA services, your voice services, whatever, teleprotection services. But then you also need to be able to manage that, right? So how important do you see the network management, end to end throughout the system in your operation? Maybe Alberto, I'll start with you.
Yeah, well, for us, it was one of the main decision criteria at the time, and put yourselves in 2004. Most IP MPLS boxes just came with CLI access to them. So basically, if you had to monitor, or even if you needed to provision something, there were several difficulties. You don't see the network as a whole. We were not coming from that world. We were coming from the world of TDM, SDH, starting to move into the WDM, and we needed a system that was different. Precisely because we are not so many people, as you may assume. Telecoms departments in utilities are not so huge, and you need to have people which are going to make the service provisioning well trained with simple tools that they can manage. And eventually, when there are problems, and there are also always problems, they need to have those network management systems that help them to troubleshoot. That was kind of instrumental. It is not just the devices, it is the services inside. Well, technology and systems have also evolved. We are having more, let's say, easiness to do that monitoring today. And that's been an evolution that you can even do outside those network management platforms. The big thing with this is, as Iberdrola, we always rely on two vendors for any single technology. This comes with a wider complexity. If you think in service provisioning end-to-end, when you want to transition from one network to the other, at first we were thinking on just mixing every single device and looking for that full interoperability, but we got rid of that idea and we connected both networks, but we have kind of separated ones. And even in those cases, you need both network management systems to be kind of aligned and offer service provisioning view to the operator, which is good enough. So those are the challenges when it comes to operations.
Yeah, I agree. And Gregory, how important is that network management for you in your day-to-day operation?
Also critical. What we are currently working on is also for the deployment of the routers, because we have many new stations to connect. So we are working on how to optimize, standardize, and also automate the creation of a new configuration of a router. So for that, we need the tools and an NMS in order to create a blueprint configuration and yes, automate the integration of this new device to be fully automated. So the same also for the monitoring, for the configuration, for the backup also, and backup and restore is very also important. So a centralized tool, it's just required today.
Yeah, I guess your view will not differ too much from that, Clint. A single pane of.
Yeah, I mean, obviously from a network, you know, of this type with you know, there's many settings and you know, features and functions and different service models and all those kinds of things. You know, having a centralized dashboard to look at certainly is the focal point of the network operations part of it. But I guess, you know, in hearing the question and of course my colleagues' responses, you know, one of the big things that we saw or continue to see is of course a bit of a separation from an operational model. Previously in the TDM SDH SONET environment, all of those alarms, all of those events, all that kind of thing, all used to go to the EMS control center. Over the last, you know, 10, 15 years or more, there's been a real separation of that, which allows everything that is sort of telecom and network based to be pulled out of that environment and almost like its own sort of control center created using these NMS tools. You know, and that is certainly desirable from a, you know, just from an operational focus perspective and skill set and so on. So that's a big one. The other one too, which I think is new to all of this, is the detailed stats collection and reporting. You know, previously in the TDM environment, right, you know, things would break in the middle of the night. You'd go out, you'd replace a card, or you'd investigate, and you know, and the light turned green and you carried on. Whereas now with the NMS tools, we get very detailed records in terms of, you know, what happened, in what sequence it happened, you know, what were the stats on every kind of service, you know, all of that kind of thing that we can then report against and so on. And I think there is an element of the NMS tools that is evolving the business process around how you operate and manage the network. You know, we kind of jokingly talk about, you know, the field folks should know before they ever leave the office to go out and do a repair or something, sort of what they need to do and what needs to be done. And so there's a whole sort of, I guess, efficiency gain that comes out of having the NMS tools that are there. And then, you know, just to what, you know, I think Gregory was saying was, you know, as we start to look at this network, and certainly as it scales, once we start talking about thousands or tens of thousands of nodes, there's also a requirement there that comes with the NMS, which allows us to standardize and template and, you know, really sort of audit the network and make sure that, especially when you have many hands working in the network as well, you know, that everything is being deployed the way that it should be and continues to operate that way. So you know, all of those kinds of, I guess you could say, business process efficiencies, I think, come with, you know, having a centralized NMS platform like this. And then, you know, I mean, we could certainly get into automation and path compute engine and a whole bunch of, I guess, newer modules that potentially fit into that as well. But you know, for now at least, yeah, the role of the simplified NMS, you know, maybe from what it used to be to what it is now is, you know, certainly greatly enhanced, you know, with the new systems.
Yeah, I guess also the fact that you know, when you get audited, you can actually show logs. There is also this idea of non-repudiation. So, you know, you can always show what happened and who has done what at what point in the network and why things have happened, right? So, yeah. For the sake of time, I want to jump.
Tom, before you
Yeah.
go on, I just wanted to make a comment on backing on Clint's answer. Let's say it is not just NMS. Let's say for us, NMS are kind of, I wouldn't say complex platforms, but they are for operators that are provisioning and troubleshooting. I think that these tools have also evolved over time, and the parts of the network we want to monitor and observe, it is not in general all the network. So we are also leveraging some of the tools, some of them open source. So I would name them, but I will not. And you can focus on having, let's say, the general state of your network, which is really helpful to understand where your pain points are, and even monitor very closely some very specific interfaces where you need to detect that there are things that are happening. So
Right.
Those NMSs coming from the product are really relevant, but also this kind of other observability tools that focus on pain points and the bigger perspective are also really helpful.
Yeah, where you can collect alarms and basically end-to-end view of yeah. No, that's a very good point.
And openness and APIs in let's say these networks do help a lot, because otherwise you are kind of locked in.
Yeah. Fully agree, Alberto. That's a very important point. Thank you for that. Now, one question that came in was, is teleprotection latency on Ethernet similar to circuit emulation? I think I have the answer to that, but Clint, I know you've been doing quite a bit of work in that space, so maybe you can give a
Sure.
first.
Yeah, I mean, the short answer is no. The latency is much lower, or quite a bit faster, if you will, when we go native Ethernet, and part of that, of course, is based on the underlying pseudowire and circuit emulation technology. You know, and without getting to maybe all the bits and bytes of it, I mean, it's we're talking about, you know, single-digit milliseconds in terms of pseudowire. We're talking about tens of microseconds in terms of Ethernet. You know, my one request, if there's relay vendors and manufacturers that are listening, and that is to go to gigabit interfaces on their relays. You know, the faster the bits get into the network, the faster we can shunt them across the network. And so, you know, with low-speed serial, that's really the constraint, right? It's not the transport network at all. We're literally waiting on the bits to arrive. So, you know, and so from the current standard, if you can call it that, which is 100 megabit, you know, versus say 64 kilobits, you know, it's many orders of magnitude faster to go Ethernet. So, so yes, definitely there's an advantage there for sure.
Yeah, I guess the one caveat there is that, of course, you need to have a very solid time synchronization if you want to,
Correct.
You know, deploy 87L on native Ethernet. So, but that would be a whole different webinar discussion, I guess. So. And then the next question is also interesting, and you kind of alluded to that earlier, Clint, was when we discussed the services on Ethernet-based protection systems, etc., and the move to packet. Is there any experience with segment routing technology as an evolution of IP MPLS in OT networks in power utilities? You know, anybody here on the panel, but maybe Clint, you have some.
Sure. Yeah, very recently, of course, one of our clients has been seriously looking at segment routing. You know, there's always this element of, if it isn't broke, why fix it? You know, with RSVPTE and in terms of the signaling protocols and those kinds of things, and those sort of tried and tested models. And so many utilities, of course, looking at teleprotection on MPLS, will obviously have to use RSVP-TE. But inevitably, the question comes up around segment routing, and why aren't we looking at segment routing? And that seems to be sort of where the emphasis is and the evolution, if you will, of IP MPLS. I haven't seen any doing teleprotection specifically on segment routing, but we have seen several now that are in the process, I would say, of deploying perhaps non-teleprotection services, using segment routing. And I suppose the beauty of the platform is that we can dual stack the routers, so we can run segment routing with really minimal risk, if you will, to the underlying RSVP based services and that kind of thing. So yeah, literally just as you know, Dominic, last month we were just how shall we say, testing or discussing some of these solutions and how one might move forward with segment routing, perhaps as a future looking model. But I haven't seen, I know there's a few examples that are out there. I myself haven't specifically had any hands-on with teleprotection on segment routing, but I think it'll be coming here very soon.
Yeah, we know some customers are already using it, have used teleprotection with segment routing, and I guess the benefit of the path computation entity,
right,
or function, to get that kind of end-to-end seamless provisioning is probably the biggest benefit of that SDN type of approach that you get from segment routing.
right.
Let's see. Well, a very good question, and I'm not sure we will have enough time to that one, is where does one start if they are planning to migrate to MPLS? Anybody want to take a stab at that?
I'll give you the quick answer, because I know Alberto and Greg can certainly add to it as well. But to summarize it up in maybe 30 seconds or less would be to say, identify your requirements, right? What kind of services, what are the specific functional requirements, that kind of thing that you need to meet, right? We need to take a look at the current network and its current topology and technology and so on. Presumably it's a TDM, SDH or SONET type of environment. You need to look at the size and the scale, right? And then one of the big ones that I, as a consultant, I suppose, working in this space, one of the big ones I always look at is, what's the roadmap for each of those services, right? What are the skill sets that the folks that the team has that are running it, and that kind of thing. What kind of where are we starting from, I guess, is really what it boils down to. And then from there, of course, it sort of goes back to that question about the industry assessment and what's the majority of our utility colleagues doing and that kind of thing. And perhaps those efforts, if you will, I guess up front, can help to set that plan and framework, I guess, put that together as far as how you would upgrade and eventually evolve to a full MPLS type network.
Yep.
But I'll pause there because I know it's there's a lot of pieces to it.
Yeah, I think Alberto also wants to chime in on this.
Yeah, because it reminds of a conversation with a fellow colleague in another utility. But first thing is, let's say, focus on the technology you have chosen. Do not go as open as I can do IP MPLS or MPLS-TP or carrier Ethernet. So focus on the one you have decided. Then you need to engage customers. That is key. You will not be alone in this journey. You are not going to force anyone. So while you engage your customers, train your people. Train them in networking. Do not assume and not just focus on the, let's say, experts, but on the rest of the organization. Go back to basics. They should be reviewing their knowledge of layer 2, layer 3 services, evolving to MPLS. We think that is crucial. And then once you are there, focus on the core and let's say some simple first services you can control. Establish those quality of service things, and let's not move to the edge till you are sure that those big important controllable services are the ones you need.
Yeah, and I guess you mentioned that also, Gregory, earlier when you said your customers, the protection people, the SCADA people, you really have to get them on board, make them part of the project, right? So
yes,
that's an important success factor.
We are working for them, so it's yes, it's the only success factor for me.
Yeah. All right. Yeah, we are 1 minute from the end. I'm not sure if there's any final thoughts here before we conclude. In any case, I would like to express my sincere thanks to all of you, Alberto, Gregory, and Clint. Clint, I know it's very early in the day for you where you are, so thanks again for spending the time with us. And Alberto, I'm happy that you didn't have to leave the room. So you're on.
I'm muted. Probably you have seen me looking through the window because I was listening to voices, but nothing
Okay.
happened. Thanks for that, and thanks to the audience. They were so resilient. They stayed till the end.
Very, very, very good. And thank you also, Gregory, for joining us. I know you were also on the move, so it's been a challenge to get everybody on today's webinar. So thank you so much, everybody, for your time and your support to this. So I guess we are ready to close. Ashley.
Thank you, Dominique, Alberto, Clint, and Gregory. Thank you for the insightful discussion. Lots of food for thought today, and I'm sure that our audience will continue to reach out for more details and support. On behalf of Nokia and Enlit, I would like to thank you for sharing your valuable insights with us. And audience, thank you for joining us today. We would also like to invite you to take a short survey. You should see the link appear very shortly in your chat box. I'd also like to remind you that a recording of today's webinar will be available on demand on the enlit.world website. Keep well, and we look forward to hosting you again very soon.
Thank you all. Bye-bye.
Bye-bye.
Thank you.